In this presentation, we're going to talk about the S-Frame solver diagnostic messages, in particular about message MO003, stray node. This video is part of a series of videos that focuses on solver diagnostic messages. If you're not familiar to this topic, we have a separate video with a proper introduction to this subject. We're going to study this model you see here, a wooden platform with supported steel beams. Let's see. And here's the platform model. You may already be familiar with this model and the properties I've defined from previous examples, but let's just go over the properties. So I have an I-beam section assigned to my steel beams. The material I'm using is steel for the beams and timber for the platform. I can see I have some fixed supports to the wall at the end of each beam. And if I go to the loads window, in this case, I've defined a fourth load case called distributed load. So if you remember, I have these three previous load cases defined. So let's just display those loads. 200 kilonewtons at the top of each beam. The vertical, the horizontal, I just have 5 kilonewtons in the x direction. The self-weight of the structure, and the distributed load, which I have applied as a pressure load. So each shell has a value of 15 kilonewtons per meter square. And I'm interested in looking at the contours of my structure when subjected to a linear static analysis. So if I go to Analyze and run a linear static analysis, I see one message displaying FYI MO003, a stray node, and the number of the node is 335. In this case, I just have one node showing, but in many cases, I may have more than one, even hundreds of them. If I switch to the geometry window, the first thing I should check is the model tolerance I'm using. So if I go to File, Integrity Checks, and maybe this is model tolerance that is too big, I'm just going to decrease it maybe 10 millimeters, and I can ask S-Frame to show me the integrity issues. So if I click the search button, S-Frame has encountered some integrity problems. So I click OK, like this one, a stray node. In this case, it's showing the same node as the solver was telling me. I'm just gonna ask S-Frame to show me where this is located. It's gonna generate all these folders. And if I go to the stray node folder and display the unselected objects, I can see this node is not connected to my structure. I should be able to connect this node to my structure using the Edit, Analytical Model, Connect Intersecting Members and Joints. If you're not interested, you can always delete it. So if I select the Join tool, with Control, I just click and drag over that node and it will be deleted. If you're not sure about how these nodes appear in the first place, it could be to some modeling, or the most common case we have seen from clients is when they import from a third-party product, such as a DXF file from AutoCAD, ETABS, STAT, Revit, etc. It's always recommendable to check your integrity checks before proceeding. Now that I managed to delete that node, I can proceed again and run a linear static analysis. In this occasion, it comes with a clean solution, and I can start accessing my results, such as the contours for the distributed load I was looking for. You can stop displaying your loads and you can start checking on some of your results, such as deflection, or maybe the stress, etc. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.